Welcome everyone. Today through this video I will discuss combination. Today I will solve some problems of combination using symbol of combination. So I have already discussed what is permutation and combination and what is the difference between them. Listen again. What is combination? Combination. I have already discussed it. Suppose ABC are three things. ABC are three things. And we like to select from these three things, taking one at a time. So one at a time, it will be A or B or C. Taking two at a time, AB, BC and CA. We are forming group or we are selecting, not arrangements. In case of arrangements, AB and BA, we are getting two arrangements. And taking three at a time, A, B, C. So, what is combination? We have already stated each of different selections. You remember it. Each of different selections or groups. Each of different selections or groups from several things taking some or all at a time. So out of three we can take one or two. So taking some, and taking out of three we can take three at a time. So all at a time. Each of different selections formed by taking some or all at a time is called combination. So look, in case of combination, order is not important. Look, AB, we are taking only AB. BA is not included because in a group AB and BA are same. So order is not important. So you say at least what is combination? Combination is selection. Selections of things. Next, we have already discussed combination of n different things taking R at a time is denoted by NCR. So C stands for combination, or we can write this as C n comma R. NCR or C n comma R, and NCR equals to factorial n by factorial R into n minus R. So R lesser than equals to n. All of you know it. So this is theorem. Selection of n different things taking R at a time is denoted by NCR, and NCR equals to this. So this will be our working tool. Today we will solve problem using symbol only. Now there are some theorem 1. NCR equals to NC n minus R. combination of n different things taking r at a time is equal to combination of n different things taking n minus r at a time. So this theorem, it is known as complementary combination theorem. For example, look, 10C3 equals to 10C 10 minus 3. This is 7. So proof of this theorem is very simple. You expand left hand side and right hand side, you get same. So LHS factorial n by factorial r into n minus r. Now what is RHS? NC n minus r. So factorial n by factorial n minus r, and this is n minus n plus r. So same thing we are getting. So LHS equals to RHS. So you recall only the result. Then second one, Theorem 2. Theorem 2. Not in order, you can, there is no definite order that this is Theorem 1, this is Theorem 2. So I am writing it Theorem 2. If NCR equals to NCS, then R equals to S, or R plus S equals to N, or R plus S equals to N. So look, NCR equals to NCS, so upper suffix are same, so R equals to S is obvious. This is obvious because upper suffixes are same. Now by complementary combination theorem, we know NCR equals to NCN minus R, NCS as it is. So upper suffixes are same, so N minus R equals to S. So what is R plus S? R plus S equals to N. So this is proof. So no need of proof, we need only result. Next, Theorem 3. NCR plus NCR minus 1 equals to N plus 1 CR. This is Theorem 3. So upper suffixes are same, lower suffix differ by 1. So add 1 to upper suffix and lower suffix is getter of R and R minus 1. So proof, LHS factorial n, if we expand this one, factorial R minus 1, N minus R plus 1. Then rule is we have to expand the getter factorial. So what is getter factorial? So this one is unchanged, R and R minus 1. So R is getter with respect to R minus 1. N minus R and N minus R plus 1. So this one is getter. So 1 by N minus R, this one is unchanged, R minus 1. N minus R plus 1, this is N minus R. So factorial 10, what is your result? 10 into factorial 9. So using this. So take common factorial n by R minus 1, N minus R common. So we get 1 by r, 1 by n minus r plus 1. Now next step. So this result is important for board problem. That is why I am giving the proof. Now LHS, factorial n, factorial r minus 1, n minus r. And LCM is r into n minus r plus 1. And n minus r plus 1 plus r. So this is n plus 1. R cancel, omitting one step. Now look, we can arrange it n plus 1 into factorial n, r into r minus 1, n minus r plus 1 into factorial n minus r. So, by the above theory, factorial 10 equals to 10 into 9. So, this is factorial n plus 1 and r into r minus 1. So, this is factorial r and this is n minus r plus 1. So, if you expand it, n plus 1 cr. So, factorial n plus 1, factorial r, and difference of this is n plus 1 minus r. You get RHS. So, you recall the result. Numerator equal, denominator differ by 1. Mind you, differ by 1. Then, this is n plus 1 cr. And finally, Theorem 4. Theorem 4. Theorem 4. NCR by NC r minus 1. N minus r plus 1 by r. N minus r plus 1 by r. Proof is very simple. So, you try it, expand and you get a result. How to recall this result? Ratio of two consecutive, look, NCR by NCR minus 1 symbol. So, difference of suffixes of the denominator n and r minus 1. So, difference is this, lower suffix of numerator. So, this one. So, proof is very simple, left to you. So, these are the 4 working tools. Today, I will solve only problem using these 4 theorems. So, these results are most important for solving problem of binomial theorem also. Now, we consider 3 problems of same type. Now, we consider problem number 1, A, B, C. They are of same type. So, 1 marks problem, NC8 equals to NC2, n equals to what? So, NCR equals to NCS. So, R equals to S or R plus S equals to N. So, 8 equals to 2 is not possible. So, what is N? 8 plus 2, 10. Now, similarly, you solve the second one. NCR equals to NCS. Upper suffix same, so lower suffix must be same. N plus 5 equals to 2n minus 1. So what is n? N equals to 6. N equals to 6. N is positive, so this value is possible. So what is the second option? Sum of lower two suffixes equals to upper suffix. So 3n equals to 25 minus 4, so 21. So n equals to 7. So problem number C. 8CR minus 7C3 equals to 7C2. Find n. So look, 7C3 and 7C2 are conjugated. So we can use formula. So look, 8CR equals to 7C3 plus 7C2. If you take 7C3 in LHS, you cannot use formula. That is why we are transferring 7C3 to right hand side. So by well known formula, NCR minus 1, N plus 1 CR. So upper suffix same, lower suffix differ by 1. So this is 7 plus 1, getter of 2 and 3. So this is 8C3. So what is R? R equals to 3. Or R plus 3 equals to 8. 8CR equals to 8C3. So R equals to 3. Or R plus 3 equals to 8. So R equals to 5. So find R, not N. So using NCR equals to NCS. These are very simple problem. Next, now we consider second type of problem using this theory. NCR plus NCR minus 1, N plus 1 CR. So this is our working tool. So problem number 1. So 1, 2a. So what is LHS? NCR. 2 into 2 separate. NCR minus 1. NCR minus 2. So we can use this formula when upper limit is same and lower limit differ by sign only. Lower limit differ by 1 only. So we can write it, you look this as so this is 2 into NCR minus 1. So adding 2 times. Now what advantage we are getting now? No, we can use formula here and here also. NCR plus NCR minus 1. NCR minus 1 plus NCR minus 2. So applying this formula, N plus 1 C R and N plus 1 C, getter of R minus 1 and R minus 2. So again we can use this formula, this is R minus 1. R minus 1 and R minus 2. R minus 1 is getter. Again we can apply the above formula. Upper suffix same, lower suffix differ by 1. So N plus 1 plus 1. So N plus 2 CR, getter of lower suffix. So this is our right hand side. Now problem number B and C. They are exactly same. So this one, problem of JEE main also and WB JEE. So you consider left hand side. So this is 52C4, I think. 52C4. So LHS is 47C4. Then we expand the summation symbol. J equals to 1. So this is 51C3. J equals to 2. This is 50C3. J equals to 3. 49C3. J equals to 4. 48C4. J equals to 5. 47C4. So 1 to 5. 1, 2, 3, 4, 5. Now we try to use this formula. So upper suffix same, lower suffix differ by 1. Lower suffix differ by 1. So look, this one is 3, sorry. This one also 3. This 3 is fixed. So 51C3 unchanged, 50C3 unchanged, 49C3 unchanged, 48C3 unchanged. This is 47C3 plus 47C4. This one. Now use formula here. So 51C3, 50C3, 49C3, 48C3. This is by the above theory. This is 48C4. Get out of 3 and 4 and add 1 to the numerator. Again we can use formula here. So 51C3, 50C3, 49C3. This is 49C4. 49C4. So again we can use the above formula. 51C3, 50C3, 50C4. Get out of this. Now again it is 51C3 plus 51C4. So actually it is 52C4 equals to RHS. Most interesting problem. So look, you pair this one, then automatically you get formula with the previous one. Now there is a shortcut rule also for competitive exam. So you look the first term. If you expand it, you look the first term. First term is 51C3. So answer will be add 1 to the suffix, upper suffix, and 1 to the lower suffix. So 52C4. For example, look, you complete B, but for this problem, look, if we take R equals to 2, this is 23C2. 23 then this one. So look at the problem again. So it is written in wrong form. This is 4. This suffix is constant. So 23C4. 23C4. C4, then 3, so 22 C4, then 3, 21 C4, then 20 C4, 2 to 5, 1, 2, 3, 4. Answer will be, I have already stated. So you proceed and final answer will be 24 C5. Add 1 to here, add 1 to here. So you verify whether this is correct or not. So shortcut method is expand the sum, then add 1 to upper suffix and lower suffix to the first term. So you must practice problem number B and C. Next, 3. NCR minus 1 is to NCR, NCR plus 1, 3 is to 4 is to 5, find N and R. NC4, NC5, NC6 are in AP, find N. This is problem also JEE Main and WB JEE. So both are. This one also. So what is the working tool? NCR by NCR minus 1. Difference of suffixes of the denominator, lower suffix of the numerator. So consider problem number B. NC4, NC5, NC6 are in AP, find N. So NC4, NC5, NC6 are in AP. Therefore, twice of second term NC5 equals to NC4 plus NC6. Twice of second term, first term plus third term. Now, expanding it and cancelling factorial symbol, you can find N. But we use this theory. It will take minimum time. So divide by NC5. So NC4 by NC5. This is NC6 by NC5. Now NC6 by NC5. This is ratio of two consecutive coefficients. So n minus 5 by this theory, n minus 5 by 6. N minus 5 by 6. Now this is 4, this is 5. So we know formula of NC5 by NC4. So n minus 4 by 5. This is formula. NCR by NCR minus 1. 1 less in suffix. So look, 2 equals to NC4 by NC5. So this is reciprocal of this. So 5 by n minus 4. And this is n minus 5 by 6. So no need of expanding in terms of factorial. So this is quadratic equation and you solve it. So 2 equals to n minus 4 into 6. So 30 plus n square minus 9n plus 20. 30 plus n square minus 9n plus 20. So 12n, 6 into 2, 12n minus 48 equals to n square minus 9n plus 50. So n square minus 9n minus 12n. So this is 21n. N square minus 21n plus 98 equals to 0. So we are getting a quadratic equation. So solve it. N minus 14 into n minus 7 equals to 0. Actually 21 is 14n minus 7n. So n equals to 14 and n equals to 7. Both are positive integer. So you can take both n 14 and 17. But look, if you get n as integer, but in this case if you get n equals to 4, then it is n equals to 4 or 5, it is not possible, although this is an integer, because 4c5 is not defined, 5c6 is not defined. So n must be greater than suffixes. So here n is 7, it is greater than 6, greater than 4, greater than 5. So n equals to 7 also possible. So you practice you solve problem number 3a. This is of same type using this theory. So through this video, we have solved some important problem of combination relating symbol of NC. So in the next class, I will solve some more problem using this definition only, NCR. So thank you for today.